So we're starting out this meeting about the dehumidification process, the project that's planned for the Southwest plant. Adam Hendricks and Samantha O'Connor are going to be providing the presentation. I do want to note that we are recording this just for the public record for anyone that doesn't make it to the meeting. And we'll be sharing that online as well. And we'll try to save, at least 15 minutes at the end of the meeting to have a few questions, but if you can't get your question in, we have an email and a mailing address as part of the invitation, so you could just send it to that. So I guess without any further ado, I'll hand it over to Adam.
Thanks, Brian. I am going to share the slides as soon as I figure out Zoom updated today, folks. It's very upsetting.
Of course it did. Why wouldn't it?
All right, can everybody see those slides?
Yep.
Perfect, thanks. Thanks everybody for coming today. Today we're going to be talking about a forthcoming capital project for the Philadelphia Water Department that is the construction of a Sidestream treatment facility. To kick things off today, we start with a disclaimer slide because there are some costs in here and there is some information that is time specific, right? And so lawyers, finance people love us to include this disclaimer slide. Basically what it means is that we're presenting facts to you that are relevant as of today. Tomorrow, a bunch of pricing information could change, a bunch of other related information could change, and some of the facts in this presentation could change just by the nature of the way the world works. That's all it's there for. But just to keep moving, working through the presentation today, we're going to try and keep things high level. We're going to walk through purpose, an introduction to the department for those folks who aren't as aware of everything that we do on a regular basis, a background of the project itself, some of the drivers for it, and then close out with a bit of a closing statement, and it's time for Q&A. So just to kind of give a quick introduction of some of the PWD folks on the call today, which there are a lot of us here today. I think there's a lot of folks who are interested and care about this project a lot. But the people you'll be hearing from the most are from the Planning and Environmental Services Division, myself and Samantha O'Connor, who are very involved in the planning of this project and involved in a lot of other ammonia removal related activities that PWD is doing. From our Public Affairs Division, leading things off is Brian Rademakers. From our Engineering Division, Nicholas Parisi and Mark Botten, a consultant from Hazen & Sawyer, who was instrumental in design of the facility. And then from Finance, our Finance Division, our Deputy Commissioner of Finance, Lawrence Gangley, is on the call as well, along with other folks throughout the department who have an interest in this project. As far as purpose goes, today,
Hey, Adam.
Adam, we lost your audio. Yeah.
It looks like you got muted.
We did.
I did.
Yeah, there you go.
Mhm.
You're muted again.
Sorry about that. Are you good?
Yes.
Okay.
No.
All right. Sorry about that. Where was I? And so as this is a public notice meeting, we tried to cast this to a presentation to a broad audience. So we're not going to get in the nitty-gritty details too much on the wastewater treatment process or necessarily even how the process works. There are enough technical folks on this call that can answer questions of that nature, but we try to keep it pretty high level to meet the needs of a broad audience here today. Quick introduction about PWD, and most of the folks on the call are probably aware. We are an integrated one water utility that serves mostly the city of Philadelphia, but also some surrounding communities as well. On the drinking water side, we have 3 drinking water treatment plants. We treat about 200 million gallons of water a day that is delivered to customers. We have over 3,000 miles of water mains in the street and about 25 pumping stations. On the wastewater side of the utility, we have 3 water pollution control plants. Treat about 430 million gallons of wastewater a day, which peaks dramatically during wet weather events. 3,700 miles of sewer, 19 pumping stations, and 1 solitary hot solids handling facility, which plays a role in this project. On the stormwater side, again, the city is roughly 60% combined sewer, 40% separate. And, I'm sure a lot of folks are aware of our Green City Clean Waters initiative, which is our plan to reduce combined sewer overflows through green stormwater infrastructure. This project is specifically focusing on the wastewater side of the utility. Specifically, will be located at one of our water treatment plants, and also that is tied into that biosolids handling facility as well. Some background details. This project has been a long time coming, and even kind of before this timeline takes over, there was some early studies that were done at the water department on Sidestream treatment. There were some plans in the 2013, 2014, 2015 era, where we were looking at doing this project in an existing aeration basin. By the time 2017 came around, we had done additional wet weather planning at the Southwest Water Pollution Control Plant that really showed that we need that aeration basin. So we had to pivot. We had to do additional planning and evaluation to really make sure not only that we were utilizing that aeration basin where we needed it, but that we were also planning with up-to-date information on some of the advances that have been made in Sidestream treatment in the industry in the last couple of years. So we completed our Sidestream treatment planning evaluation in 2019, put out a contract to design the facility, and began a detailed design of Sidestream deammonification facility right before COVID hit, which caused, again, some delays as everything got delayed. But here we are with a completed design. Permitting is pretty much wrapped up on the facility, and we are ready to go forward with this PennVest funding application, which is why we're all here today. To give a bit of background of the facility, so the Sidestream treatment facility is designed to reduce the ammonia discharge specifically at the Southwest Wastewater Pollution Control Plant. The capital cost of this facility is estimated to be approximately $74 million. And as of now, we're planning to have that facility in operation in 2027. And again, as we talk strategically as a utility to try and lessen the burden on ratepayers for a facility of this size, we are planning to apply for a low interest PennVest loan for the project. The next application deadline is in February. That's the one that we're targeting. And if the loan is awarded, the project will be bid in summer 2024. And this public notice meeting, again, is a requirement of that loan application. Just so folks get a kind of an overview here, this is an aerial shot of the Southwest Water Pollution Control Plant. Aerial footage, again, the real quick overview, the Southwest Water Pollution Control Plant starts kind of in the bottom left-hand corner of the screen with what are called primary tanks that start to remove solids from the process, moves into aeration, and then into those final settling tanks, which is the big set of water basins on the screen. Above those processes are our sludge digesters. And then if you look to the top right of your screen, what you'll see is our Biosolids Recycling Center, which includes dewatering of digested sludge and also drying to produce a Class A land-applied biosolid product. That facility is currently operated by Synagro, where Sidestream fits in is right next to that Biosolids Recycling Center. There's a parcel of land that's kind of between Southwest and some administrative buildings and the Biosolids Recycling Center, which is a good plot of land to build a new process facility. It also is, as this facility is targeting water that is coming off of our dewatering facility at the Biosolids Recycling Center, it's the perfect location to really just pump that stream right into the Sidestream facility, remove the ammonia from it, and send that stream back to the headworks of the plant, which is where it goes untreated today. Again, here are some visuals from the plans of the project. You can see it's a fully enclosed building where the processes will have. Down at the bottom are some current pictures, where it's just kind of a vacant plot of land. And then some pictures of the building after construction, what it will look like. And with that, I am going to hand things over to Sam O'Connor, who will walk us through the rest of the presentation here today.
Thank you, Adam. Great job. Let me know if I suddenly become muted. So project drivers, why are we doing this project? So first, a driving force is regulations specifically on ammonia discharge to the Delaware River. So in terms of a presentation tailored for the public, we wanted to start with, where does ammonia come from? So we have a toilet, fitting, and in wastewater, which can come from people and washing machines, cleaning products, things like that. Ammonia can be found in meat, blood, different cleaning products. And basically when you flush your toilet, the wastewater eventually gets conveyed through our sewers to the wastewater treatment plant. At the wastewater treatment plant, we treat for solids, oxygen removal, and then we discharge our treated effluent to the Delaware River. This treated effluent contains ammonia. And if we look a little closer at the Delaware River side of things, the ammonia basically that's discharged from the wastewater treatment plants eats up the oxygen in the river as it converts to nitrate. Over on the right-hand side, you get a little chemistry lesson for those of you who have not taken chemistry in quite a bit. But basically starting with the ammonium and oxygen converting to nitrite, taking up more oxygen, converting to nitrate, leaving less oxygen for the fish. So that's the issue in the river. And from the wastewater treatment plant perspective, since the 1970s, wastewater treatment plants, particularly PWDs, of course, have been equipped to remove organic material, which reduces the carbonaceous biochemical oxygen demand, or CBOD, coming out. And that's what the regulations have sort of been all around on and what treatment plants have been designed for. However, increased treatment and therefore more infrastructure is required to move ammonia and thus reduce the nitrogenous biochemical oxygen demand of treated wastewater. In a very quick summary, our plants weren't designed to do this as they currently stand. Kind of furthering the point of like where we stand on our wastewater plants. So PWD collects the largest municipal load of ammonia in the Delaware River Basin, which is discharged to the river due to the existing treatment limitations at our plants. So if you see our effluent ammonia here on the side, and I'll just describe this map briefly, in the whole area, the whole colored area is our drainage area. The striped represent the wastewater we collect from the suburban communities, and the solid represents the city. The northeast plant is in all the green, the southeast plant is in all the blue, and the southwest plant is in all the coral. So as you can see below the treatment plant titles, we have our effluent ammonia concentrations. And, as people change what they eat every day, our wastewater effluent changes every day. So our effluent ammonia ranges at the northeast plant from 4 to 10 milligrams per liter. Southeast plant, it ranges from 6 to 10 milligrams per liter. And at the southwest plant, it ranges from 14 to 26 milligrams per liter. Now, this is based on average effluent level ranges from 2014 to current November 2023 weekly sampling data. So impending regulations could limit these concentrations of ammonia discharged from wastewater plants. But basically ahead of that, PWD's Sidestream facility at the southwest plant is a voluntary commitment to increase in-stream dissolved oxygen levels. As you can see, the southwest plant has the highest level of discharge. We'll get into why in a bit, but this would help to reduce that bottom number, that 14 to 26. It would help to reduce that. Now moving into the cost effectiveness. So jumping into the southwest plant specifically, we have a couple different influent sources. And if you see the legend on the very bottom of the screen, in blue, we have Delcora, In red, we have the high level that's from the city and then some suburban communities that take, sorry, the chat popped up in front of my screen. In the green, we have the low level system, also contains city sewers, but then also our Biosolids Recycling Center recycle flows and the plant drain. And then in the purple, we have BRC centrate, and in the blue, we have BRC condensate. Basically, like I said, the BRC centrate is Biosolids Recycling Center, the centrate that comes off of the dewatering process, basically removing the water from the poop. And the condensate comes off of the dryers when we dry the poop into Class A biosolids product that are land applied. So those two streams, that's what's meant by centrate and condensate. On the right-hand side, you can see the influent flow. So the same colors, same sources, but just note that basically we have a breakdown of ammonia loading by source, and we also have a flow breakdown by source. And they're not always the same. And I'll focus in on the centrate for a bit when we talk about the cost effectiveness. Mass load in terms of pounds per day on the left-hand side. I'm just seeing the chat come up, and I know we can respond in writing, but I figured I'd respond live now. Yes. So in terms of mass load on the left-hand side, and then on the right-hand side is in terms of million gallons per day. So just like taking that pie chart, making it a visual, you can see the arrows coming in. This is all coming into the head of the plant. So you have the Delcora in blue, the high level in red, the low level kind of coming across from a couple different sources in green, and then the BRC centrate in purple. So by basically tackling this large, on the previous slide, we saw that it was the BRC centrate ammonia load is about 30% of the plant's influent ammonia load. If we can tackle that, or at least a portion of that, before it even hits the plant, you're looking at a much more cost-effective project to reduce ammonia than if you were to tackle the whole plant, considering the flow rate of the whole plant. We have like another, if you advance, Adam, we just have a bullet to kind of like drive that point home where if you break this out from a cost per pound of ammonia removed, if we were to try to tackle the whole plant right now to remove ammonia, we would be looking at $41,000 per pound of ammonia removed, and probably a much longer timeline. Whereas if we start now by tackling the BRC centrate, we're looking at about $9,000 per pound. So in short, to quote one of my colleagues who I think is on this call, Sidestream is the biggest bang for our buck when we talk about reducing about 10% of PWD's total ammonia load to the river, which is a pretty significant portion. And just kind of dialing it back up, if you can see that those highlighted portions in purple, the Sidestream facility will tackle this chunk of 30% to basically remove that by 85% of it, not to throw out a bunch of percents, but that chunk will basically only be 5% after the Sidestream facility is done. And like you can see on the right-hand side, that flow is very small in the context of the larger plant. Less footprint, less money. So just like Adam said, we're not really getting into how exactly the treatment process works, but just to kind of understand the flow path. So we start with innaprawuent, who's operates the facility on site at the Southwest plant to recycle our biosolids. So we have the centrate that sort of comes out of the centrifuges there, and in the flow path, then we have the Sidestream facility where we have an estimated 85% reduction of ammonia from that centrate line into the Southwest plant. Enter the Southwest plant, you get in terms of like the plant effluent, about a 25% reduction out of the Southwest plant numbers, and then to the Delaware River, as we mentioned, an estimated 10% reduction in PWD's total NBOD load, or total municipal sources NBOD load into the river. So just like in terms of how that flow path kind of works. And then just to recap some of the main points, PWD has designed a Sidestream treatment facility to reduce ammonia discharge from the Southwest plant. The project is driven by regulations, aquatic life health, and cost effectiveness for reducing that ammonia discharge. The facility's capital cost is estimated to be $74 million. PWD plans to have the Sidestream facility in operation in 2027. And then to lessen the burden on our ratepayers, we're seeking alternative funding via Penvest for a low interest Penvest loan. And then basically the timeline for that is early February. And if the loan's awarded, we would be bidding the project in summer of 2024. And as a requirement of that Penvest application, this public notice meeting we're having today, along with a comment period, as Brian mentioned, if you wanted to email comments and questions in outside of this meeting. And with that, we'll wrap it up for Q&A.
Thank you, Sam. I think we're gonna jump up to Rob Ballinger, see if we can talk to him. Do we have Lawrence in the meeting?
Can you hear me?
Yep.
Yeah, thank you. Yeah, so Robert Ballinger had a question about, have we sought forgivable funds or grants from Penvest?
Yes, we have. According to how Penvest works is that we submit our application and they evaluate it for whether it is grant or loan. So we are submitting this application and they will evaluate it. But if we just talk a little bit about our past experiences, is that we have now qualified for grant or loan forgiveness because Penvest has judged us that our rates are affordable. Before you can qualify for, under the current interpretation for grant, your water rate has to be more than 2% of your median household income. Your sewer, that will be more than 2% of your household income. And your stormwater, 0.5% of your median household income. That comes to about 4.5%. On our rate filing, we had 1.7% of a typical bill median household income. So that makes us not to be a disadvantaged community based on current interpretation. So that is where we are. We submit the application on the same. They ask us for supplemental financial statement that we present our financial statement in water, wastewater, and stormwater. We have done that. We have also separated our EDU, that's the equivalent domestic unit for our residential and non-residential. We've submitted all of those things. So we are waiting for their decision, but based on our past experiences, we are not overly hopeful that this may qualify for other than room. But as I say again, we presenting the application for what interpretation Penvest we give.
Thank you, Mr. Yangle. If I may, there was actually a question that preceded mine from Ruben David that I think would be important to address.
Yeah, I think that's a good point. Just kind of to jump on that, what we're trying to explain is, much of the financing that we do for large capital projects needs to come from loans. We cannot ask our customers for money straight up for these projects all the time, on a day-to-day, month-by-month basis. So we need to borrow money, and something like Penvest allows us to do that in a sustainable manner, where we have a project like this where it's going to cost tens of millions of dollars. We're not going to ask our customers to pay for that up front. We're going to spread it out over 20 years, the low interest loan if we can do so, and have the benefits to the city as we do so without overburdening customers.
I understand there was another question you wanted me to address.
I guess the one about the surrounding counties from Ruben regarding, we have like the outlying community agreements, and it's not necessarily the same structure as like our ratepayers that with the water bill and all. So maybe if you want to touch on that, Lawrence.
Let me just understand the question. Me to comment on the surrounding counties?
Uh,
I guess just the wholesale like contracts and how they do have a part in paying for investments, but it's a different structure than what you do when you're a ratepayer.
Right.
So I guess maybe just a little glimpse into how outlying communities pay for their appropriate portion of investments that we make.
Okay, let me just summarize that quickly. When we pay our wholesale customers, the surrounding communities, they also pay for what we call return on investment, which investment we make, and it's stated in the contract. They also pay for the share of depreciation. So through the return on investment and their share of depreciation, they are able to contribute to our investment. That's how we recover our capital costs from our wholesale customers.
If we move down the question list a little bit, I think we tackled a lot of the earlier ones, and then we get to Gary, who I think has a really good and valid question that we have internally talked about a lot with respect to this project that I think is good to highlight. So Gary's question was, how viable is the BRC, or Biosolids Recycling Center, in the coming 50 years, and will this pay off long into the future? And I think that's a really good question, and one that we've kicked around a little bit in terms of our Biosolids Recycling Center, and what, the thought here would be that if the Biosolids Recycling Center goes away and we don't have a centrate stream that's low flow, high concentrated ammonia coming back to the plant, we wouldn't have need for a side stream facility at all, or use for one. However, current technical advances in the industry, I don't see anything coming down the pike anytime soon that would limit the need for dewatering of solids, right? Of wastewater treatment solids. It's currently best practice. Even some of the advancements in biosolids processing, you still have to dewater your solids to at least 25-30%, which is what our centrifuges hit somewhere around 25% dewatered solids. So that I don't see going away anytime soon. Even if BRC doesn't look like it does today, we will still be responsible for dewatering those solids, which means that return stream will still be coming back to the Southwest plant for a very long time. I think that was a great question, though. Moving down the list, does Delaware or any community drink the water from our water discharge from Philly? And that's a difficult one to answer. So, because I think that I think that yes, there are drinking. I don't think there's actually I don't think there are drinking water sources downstream of our wastewater treatment plants. The closest ones are just upstream. Was probably our Baxter water treatment plant is the closest one, and that is upstream of all of our wastewater treatment plant discharge points. So no, I don't believe that there are any other water treatment withdrawals from the Delaware south of us. There are other wastewater dischargers though south of us, which is what I was initially thinking of.
Adam, I just wanted to, on that topic of like wastewater treatment and I guess sampling, Robert had a question sort of in between the finance questions of has PWD measured the effluent levels in the Schuylkill? And in terms of our water pollution control plants, all three of them discharge to the Delaware. So in terms of our sampling of effluent, it would just be for the Delaware. We don't discharge to the Schuylkill.
Yeah, if I could clarify, I mean, I think it's not so much, I guess, the discharge, so maybe I shouldn't have used the word effluent, but just the ammonia levels, because every time there's a heavy rainfall, the system does discharge to the Schuylkill. So I guess I'm curious about, you know, the balance between, you know, stormwater overflow remediation and how does that affect water quality versus this project, which is tied to a specific source, and just kind of, you know, looking at both of those together, I guess, is my issue.
That's a great question, and I don't know that we have specifically looked at that, but I do know that DRBC did. And when they did their last round of modeling to kind of come up with their analysis of attainability, they looked at, I know specifically we had some back and forth conversations with them looking at CSO discharges, if those reductions would get us any water quality improvements in terms of in-stream dissolved oxygen. And I think the answer was a tiny little bit. And that is part of the assumptions, I think, that underline their modeling efforts that went into the analysis of attainability. Moving down, the proposed treatment, I believe we settled on inenomox, right, Sam?
Inenomox,
Yeah, inenomox is the technical term of the process, the technological process that we designed. There were a couple out there that we evaluated during the planning stage. Anamox was another one of them. Inenomox seemed to be the most, the one that fit best for our plants. And I think there were a lot of operational considerations that kind of edged it out of the other options that were on the market at the time. The finished, and then is the finished facility planned to be operated by PWD or a contractor? As of today, we are planning to operate it by Southwest plant staff. So it will be PWD operated. Did we miss any questions? Oh, so John Yegachek asks what the effluent ammonia concentration from the Southwest plant we are expecting once the project is completed. And it's a great question, John. I think we talk in percentages because the effluent is variable, right? So I think on average, again, it's about 20, sometimes it's 25 on average. But no matter what, it would still be that 25% reduction.
Right.
So on average, it's kind of like a 5 milligram per liter reduction in whatever the ammonia levels are on a given basis. We do have plans to kind of try and unpack and evaluate why those fluctuations exist and why, you know, aside from some of the recycle streams at the plant, why the Southwest seems to have a higher ammonia loading than the other two plants. So those are some things that we're looking into as well, and maybe we'll have more informed answers coming the next couple of years. Question about how this would affect PWD's operating expenses, and I don't have those numbers off the top of my head, but that is something that as part of planning we have, and we can certainly get back to you on that, unless someone else on the call remembers those numbers.
No, I just know that operations is, you know, sort of planning for that in advance with staffing considerations in terms of budget, but nothing like sharply increasing. But you're right, yeah, I don't have those numbers on hand either.
And anything we can't get to today, you know, I'll put the email in the chat, but it can be sent to waterinfo@phila.gov and we'll follow up.
Next question, Eric had a question with the 2027 timeline for this. What timeline is PWD looking at for nitrifications and upgrade to the Southwest facility itself? And I'm not going to sugarcoat this. It's going to be a long timeline. large capital projects, especially at Southwest, which process-wise is going to require a complete overhaul of the current aeration system in order to effectively nitrify at the plant, is going to take a lot of time between planning, design, and understanding of the capital needs, capital costs, and figuring out the timeline for that. We're also waiting with everyone else for the EPA to release their regulations, which is supposed to be coming out this week, that will really drive some of those implementation timelines for us. So it's a bit difficult to predict what the next step is for us and what those timelines look like, but I assume that once I think we've done a lot of planning on our end, and once those regulations do come to pass, we can come up with some plans pretty quickly based on kind of what those implementation schedules will look like.
And Adam,
Tom, go ahead. Sorry, go ahead, please.
One of your teams doing sort of.
Oh, I'm missing my moments of shine here.
I'm like, come on.
The other thing that I will say with sort of nitrification at our water pollution control plants is that these plants are very old, right? And we've done our planning analyses to look at kind of conventional upgrades to them. They're very expensive and they're also very complicated. There's not a lot of land. There's not a lot of great opportunities. You kind of end up having to put things in places that don't really make sense, which we can do and will do if we have to, right? But one of the things that we're also excited about that might extend our timeline a little bit is we're doing some piloting of some emerging technologies that we're starting up early, probably Q1 of 2024. So in the next 3 months, that could significantly change kind of what we're looking at from a capital standpoint for mainstream treatment at all 3 of our plants. So that is also one of the hangups with implementation. There's some opportunities for more emerging technologies to really kind of save the day here for us. But we have to prove those out through piloting. We've done some initial bench scale tests on some things that look very promising. We're doing an on-site piloting with a little containerized pilot skid early next year. And we're happy to kind of showcase that and bring folks out and walk them through that if there's an interest there as well. I think that there's a lot to talk about there that is really cool how we look at these things. And then Tom had a question that warrants some clarification. On the slide, what side should, and this is complicated, we've kind of worked through the numbers, and again, the percentages are better because average effluent kind of changes seasonally and based on industrial dischargers and stuff like that, things that we'll be investigating over time. But what Sidestream will get us at the Southwest plant is approximately a 25% reduction in effluent load from the Southwest plant. And that equates to about a 10% reduction in total municipal ammonia.
PWD, right.
Yeah, PWD load to the estuary.
So if you consider like
So-
Northeast, Southeast, and Southwest. So
Yep.
technically both are effluent numbers, Tom, if that makes sense. 25
Yeah,
is associated with Southwest, 10 is associated with all 3 PWD plants.
Exactly. We have a couple minutes here, so any folks have any other final questions? And again, Brian did put the email in the chat, so we're happy to dig into some more details if there are those sorts of questions. Definitely feel free to use that, and we'll be in touch shortly.
Yeah, thank you so much, Adam. Yeah, if anyone else has anything to add, we have our email open. There's also a mailing address that was included in the invitation. So we're going to keep taking comments on this. This is sort of uncharted territory for us in some respects because, we apply for PennVest money all the time, but in this particular situation, PennVest really wanted to get some public input on the request for this. So, we're actually really excited about this. So it's just, it's nice to kind of air this out and show what we're working on. And we look forward to having the benefits to water quality as it goes forward. And we are, of course, really hoping we get that low interest loan to reduce any impacts on our customers. I guess with that, we will call this a meeting, and thank you so much, Sam and Adam and Lawrence, for your information.
Yeah, thanks everybody for showing up and asking some great questions, and follow up and we'll get back to you.
Okay, thank you. This is Lawrence. I just heard from somebody from Penvest that affordability criteria change over time. So we hope that any change will be more favorable to us. Just that it came in, so I just want to let you know.
Thank you.
Yeah, thanks a lot.
Okay.
All right, have a good evening, all.
Have a good one.